Okay, now we're going to simplify square roots. So to simplify a square root, we're trying to see what's the biggest perfect square number that can divide in to the number that's into the square root. So perfect square numbers, 1 times 1, I could make a list of them. So you can always do this on the side of your paper. So 1 times 1, 2 times 2, 3 times 3, 36, 49, 64, 81, 100, and I'll probably stop here at 100. Okay, so we'll start with number 2. So we want to see which is the biggest number that can divide into 72. So I would start at the bottom of the list and work my way up. 64 definitely will not work. And what I mean by work is when I divide 64 into 72, I will get a decimal. So I have to keep working my way up, and I would see 36 can go into 72. 36 times 2 is 72. 36 is the perfect square, so the square root of 36 is just 6, and it comes out of the square root. This 2 is not a perfect square, so it stays in the square root. Number 5, now we have a number on the outside. So first thing we do is simplify this number the same way we did in number 2. And I want to see what's the biggest number that can go into 96. So I would start at the bottom of my list and work my way up, dividing into 96. 16 is what's going to work. So 16 times 6 is 96. And then the square root of 16 is 4. So when this 4 comes out, it's going to multiply to this 10. And this is not a perfect square, and it stays in. So my final answer will be 40 root 6. Number 8. So now we have a couple square roots here. The goal is to rationalize, which is getting rid of the square root in the denominator. So to get rid of the square root, it has to be a perfect square inside. To make 5 a perfect square, I'll just multiply by 5. Because 5 times 5 gives me 25. And then I'll multiply 5 to the top. So these two numbers should always be the same when we're multiplying, because whatever I do to the bottom, I do the same thing to the top. On the top, only what's in the root multiplies, so 3 times 5 would multiply to give me 15. 5 times 5 is 25. And then our final answer will be 3 root 15, and the square root of 25 is 5. So we got rid of that radical in the denominator. Okay, let's look at the number 9. So square root of the top and square root of the bottom. So I can always break that up into both of them being in the square root. The bottom is a perfect square, so I don't need to rationalize. Square root of 100 is 10. The top, I can look at my list, see can a perfect square divide into 8, and I know 4 can. So I can break 8 down to be the square root of 4 times the square root of 2. The square root of 4 is 2, so 2 comes out, and then this 2 stays in the root. Last step, 2 over 10, when I have these numbers outside of the root, I can reduce the fraction. So I could divide 2 out of both of these to get 1, and then 10 divided by 2 would be 5. Okay, and then we'll look at number 10. So there's a couple ways that we can do this one. I like to simplify what's in the root already. So I have square root of 3 and square root of 48. Square root of 48 I can simplify to be 16, which is a perfect square, times 3. So this would be square root of 3 over 4 square root of 3. And these, if I have the same thing, square root of 3 over square root of 3, they can just cancel out. So I'm left with 1 in the top and 4 stays in the bottom. Another way you can do this is this fraction can reduce. So 3 over 4, 3 can divide into 48, 16. So it can reduce to 1 over 16 to the square root of the top, square root of the bottom, to get 1 over 4. Either way, you get the same answer.